Hi everyone, this is Mrs. J, and today we're going to keep learning about graphing rational functions. Alright, I have a quick warm-up for you guys, so if you could please pause the video and give it a try, and then hit play whenever you're ready to check. Okay, go ahead and check your work here. So here you're asked to do long division. So here's the setup. I gave the hint, don't forget that placeholder. So that would be this placeholder for x. And the step that I always say to watch out for is that subtraction step. So for instance, right here, it's negative 2x squared minus negative 3x squared, which is positive 1x squared. Or here, it's 0x minus negative 3x, which is positive 3x. So just be careful with that subtraction step. And then our final answer should be x squared plus x plus 3. And then this is our remainder, so plus 5 over whatever we divided by, x minus 3. So when we're working with rational functions, we can be given the equation in different forms. So sometimes we'll actually be given a rational function in this form. So it looks something like ax plus b over cx plus d. So this looks really different from the form that we learned to graph from in the last lesson, which looks like this. So one way that you can tackle a rational function that's in this form is you can simply rewrite it using long division, which is why we reviewed long division in the warm-up. So we're going to rewrite the equation to a form that's easier for us to graph. So that's what we'll be practicing today. All right, so let's try this first example together. So here you can see that we have that different form, so we have 3x minus 4 over x minus 1. So before we graph it, let's rewrite it in that other form we're more familiar with. And again, we can do that with long division. So we do 3x minus 4 divided by x minus 1. So x goes into 3x 3 times, then we multiply. So 3x minus 3. And again, here's that subtraction step. Be careful, these cancel out. Negative 4 minus negative 3 is negative 1. It's like doing negative 4 plus 3. So this leaves us with 3 minus 1 over x minus 1, which we can rewrite like this. F of x equals negative 1 over x minus 1 plus 3. So now that's in that form that we're more familiar with. So we can graph this pretty easily. So here's our function. So remember, we're always going to have a vertical asymptote at x equals h, and it's always opposite. So we have a vertical asymptote at x equals positive 1. So right here, which does shift our graph to the right one. Our horizontal asymptote is at y equals k. So it's at y equals 3, and that does shift our graph up 3, just like we would expect. And then from here, we just plug in a couple x values to see where our graph falls. So so we want some values to the right and the left of our vertical asymptote. Let me zoom out a little more. So we can do maybe f of 2. So if we do f of 2, we get negative 1 over 2 minus 1 plus 3. So this gives us negative 1 over 1, which is negative 1 plus 3 is 2. So we have the coordinate 2, 2. So right here. And again, since we know which quadrant it's in, we can kind of sketch our graph just knowing that our graph will fall along the asymptotes that we have. So again, it's a rough sketch, but it will work for what we're trying to do. And then let's pick a point to the left, so we can do f of 0. So that gives us negative 1 over 0 minus 1 plus 3. So f of 0 becomes, this becomes positive 1 plus 3, so 4. So we have the point 0, 4 right here. And then again, we know that our graph is going to follow along our asymptote, so something like this. And there you have it. So again, just using simple long division, we can rewrite a function in this form into the form that we're more comfortable with, and then it's much easier for us to graph. Okay, let's try another one together. So again, the first thing we're going to do is we're going to rewrite this function in the other form using long division. So negative 2x minus 4 divided by x plus 3. So x goes into negative 2x negative 2 times, and then we multiply. And then again, be careful for this subtraction step. This leaves us with positive 2, negative 4 minus negative 6. So this is our remainder. Our remainder is going to be 2 over x plus 3, so we can write that first. 2 over x plus 3, and then minus 2. And again, we're just writing it in this order to match the form that we're comfortable with for graphing. Okay, so here we can see that we have a vertical asymptote at x equals negative 3. Remember, it's always at that h value. Our horizontal asymptote is going to be at y equals negative 2. That's the equation. And then we just need at least 1 point to the right and 1 point to the left of our asymptote. So let's start by finding, let's do f of negative 2. So we have 2 over negative 2 plus 3 minus 2. So this leaves us with 2 over 1 minus 2 is 0. So we have a point right here. And we know that our graph is going to travel along the asymptotes we have, so it will look something roughly like this. And then let's pick a point to the left just to make sure. So maybe we'll do f of negative 4. So we have 2 over negative 4 plus 3 minus 2. So this becomes negative 2 minus 2 is negative 4. So we have negative 4, negative 4. And again, we know that our graph will follow along the asymptotes, something like this. So there is the graph of this equation, which again, we rewrote using long division. I also want to point out if any of this process, graphing from this form, is not looking familiar for you or you need to review it, go back and watch my previous video and that will explain how you find those asymptotes and why our graph looks like this. Alright, so now I have one for you to try on your own, so please pause the video and give it a try and hit play when you're ready to check your work. Okay, go ahead and check your work here. So first check your long division. You should get negative 4 and then your remainder is 1 over x minus 2. So we can write it like this, 1 over x minus 2 minus 4. So this gives us a vertical asymptote at x equals 2, a horizontal asymptote at y equals negative 4, here and here. And then we can test a couple points to the right and left, and then we know, again, our graph will always follow along our asymptotes. All right, so now we're going to be kind of working backwards. We're going to see if we can look at a graph of a rational function and actually create the equation. And we'll create the equation in this form that we've been working with. So we know that the key features of our graph, well, one of them is our vertical asymptote, and then one of them is our horizontal asymptote. So those will be the two things that I look for first. So if you look at this graph here, I'll zoom in for a moment. You can see that our graph is approaching the vertical asymptote at x equals negative 2. and also this horizontal asymptote here at y equals -3. So that means that my h value is -2 and my k value is -3. So we can start by plugging those in to our function. So we have f of x equals a, which we don't know yet, over x. So remember, it's x minus our h value. So if our h value is negative, we're actually going to write x plus 2. And then we use our k value, which here is -3. But you can see that we still need to confirm what our a value is. So we can do this by picking a point that we see on our graph, and we can substitute it for x and y to help us solve for a. So we still do need to find this a value. So looking at our graph, we see a nice clear point here. So we can use this point. So this point is 0, -2. So we can substitute x with 0 and y with -2. So f of x becomes -2 equals a over, remember our x value is 0. So we have 0 plus 2 minus 3. And now we can start solving for a. So here, if we simplify, it's a over 2 minus 3. So let's add 3 to both sides. So 1 equals a divided by 2, and then we can multiply both sides by 2. So we have our a value, which is 2. And now all we need to do is substitute that back in right here, and then we have our function. So this gives us f of x equals 2 over x plus 2 minus 3. So again, to recap, we can use our asymptotes to help us find h and k. H is our vertical asymptote, k is our horizontal asymptote. And then we can find a clear point on our graph, and we can substitute for x and y to help us find a. So we always have to find a, h, and k. Okay, let's try one more together. So looking at our graph again, I can see that we have a vertical asymptote here at x equals 1, and a horizontal asymptote here at y equals 4. So that can help us with our h and k values. So far we would have f of x equals a, which we still don't know, over x minus 1, remember it's always the opposite for x, and then plus 4. Now let's look at our graph and find a clear point that we can substitute. So here I see a clear point. We have the point 0, 5. So we can substitute that for x and y. So our y value is 5 equals a over 0 minus 1 plus 4. So 5 equals a over -1 plus 4. And then subtract 4 from each side. And then we can multiply both sides by -1. So our a value is -1. And now all we need to do is substitute this back into our function. So f of x equals -1 over x minus 1 plus 4. And there you have it. Okay, so here's the last example for the video. So please pause the video, give it a try on your own, and we can check your answers in just a few seconds. All right, go ahead and check your work. So you can see we have a vertical asymptote at x equals 0, a horizontal asymptote at y equals -5. So our h value is 0 and your k value is -5. Of course, you don't need to write in this -0, but I just put it in to show that it is technically our h value. And then to find our a value, you can use either this point, 1, -2, Or you could have used this point, which is 3, negative 4, to substitute. So I substituted my y and my x, and then I was able to find that a equals 3. And again, if you use this other point, you should have gotten the same a value. So we substitute it back in, and our final equation is 3 over x minus 5. Okay, that is all for today's video. Thank you so much for watching.